morning, everyone in physics. Here in the lab, in the classroom, we have a good bit of moderately specialized equipment for measuring forces and motion and that kind of thing. So I wanted to introduce you to our simplest setup today, which we're going to use for today's lab. This is called the CPO Physics Stand. It consists of a base, a stand on which you mount various things, and in the case of motion, various tracks. There is the straight track. There is the roller coaster track. There is the loop track. In each case, we know that in order to precisely observe motion, you have to impose a grid on things. And you'll notice that each of these has a metric grid in centimeters. And the gradations go down to millimeters. Each track is typically roughly 1 to 1.2 meters long. And there's a knob up here, a wooden knob, which marks the 0 point. The basic object we use is a metal bearing. And this bearing is 0.019 meters in diameter, or 1.9 centimeters. That will become important in a way that you'll see soon. They also come in plastic of varying weights. And the basic motion is to place this up against the wooden peg and release. Now, you could release this simply by holding it with your fingers and letting it go. The problem is, as you know, your fingers might be a little bit sweaty. You might release it and give it a little bit of velocity in the beginning. So I like to try to control the release by using something hard and flat. And it's a general principle insofar as you can remove the human from the process, you get a more precise result. Now you probably noticed that the object, right, the metal bearing goes pretty fast down there. And so the question comes up how we can precisely time when it's reaching various positions. And for that, we have the timer kit. This consists of 2 photo gates, patch cords, and the processing unit that we call the timer. What we do is we take a photo gate here, and we have a simple patch cord, which is really just an old school telephone line, and we're going to plug that in the back. I'm going to plug this into A. The photo gate consists of a beam of light that starts right here and crosses between these two. We have various modes. We're going to set this to interval. And then we're going to turn on A so that the light illuminates. Now, if you'll watch, as I pass my finger through here, it records a time. And notice that time goes down to the 10,000th of a second. And here's how this works. I'm going to reset back to 0. When I break it, when my finger comes through, it's going to break the light beam, and that will start the timer. And when my finger leaves, the light beam joins back together, and that stops the timer. And you can see my finger was in there for 1.6162 seconds. Now, these timers are designed to be attached to this. So I'm going to attach this at 50. I'm going to get, there's a little metal circle here. I'm going to put that right in the center of the 50, at the 50 centimeter mark. Bring that nice and clean up against the back of the track, tighten that down. Notice how the timer is perpendicular to the motion of the track. Now what happens is, when I send the ball down the track, right, this 0.019 meter in diameter ball is going to roll down here. A certain point, if you set this up just right, the leading edge of the ball, the bearing, is going to break the beam, start the timer. And then as it moves through, it's going to roll through, and when it rolls one diameter, the light beam will rejoin. And it will give you the time it took to roll one diameter, as follows. Now clearly we could not even see that with the naked eye, but we find that it took 99 ten-thousandths of a second for that to happen. Now basically then, depending on where I attach this, I could attach it at 10, I could attach it at 20, I could attach it at 30, and on down. It will give me at that point how long it took for the ball to roll 0.019 meters. And that's the nature of the data that you're going to get. So basically, if we set this in various places, we can get a read on the velocity, almost the instantaneous velocity, right? The velocity at any given point where it took the bearing to roll 1.9 centimeters or 0.019 meters. From that, we can get the velocities, and then we'll take this off, move it down a little bit, and we'll roll the bearing through again. And we'll find that this time, a little bit further down, it only took 0.085 seconds. And you know what that means about the velocity down here. So that's the basis of the experiment. And your classmates who are in school today are going to take the data, and they're going to fill out the data table and send that out to you, and then you all are going to analyze it. So that's basically how labs are going to go when we are using the specialized equipment here in the classroom. We will keep a live feed open so that you can see the equipment. We'll just have it on the equipment so you can see that. However, while we're taking the data, you're free to log off. Just return to the Teams meeting at the appointed time, and we should have the data for you. It's then going to be your responsibility to analyze and present that data. And so for the next class period, what we'll be looking for is for each of you to have completed your position versus time and motion versus and velocity versus time graphs, and be prepared to present them so that we can see them. Okay, we want to look at least half of everyone's. For lab assessments, you will be responsible for understanding how the equipment works and how to do basic data analysis. But the key here is understanding how to get velocity from the time we get from the timer. So we're going to get to work. We'll see you back at the appointed time, and we'll look forward to seeing your graphs next period.